Hello, ladies and gentlemen. In the first chapter, we explored 10 principles of economics. The goal of this chapter was to introduce you to the field of economics and, talk about some important topics that economics deals with in general. In this chapter, Thinking Like an Economist, we will introduce you to the methodologies used by economists in the process of finding the answers that they look for. So every field that's its own language and its own way of thinking, okay, and this is what we usually call the jargon. When it comes to the language used in the field. In mathematics, for example, you have words like axioms, derivatives, integrals, vector spaces and whatnot. This is the jargon, or this is part of the jargon, the language used in mathematics. In accounting, some of you may be accounting majors. You have, words like profit and loss, balance sheet, financial ratios, and whatnot. While in economics, we also have a jargon: demand, supply, opportunity cost, absolute advantage, and many more. Okay, so in this chapter, we will learn the economist way of thinking. Okay, we'll study the approach that economists use, when they try to find answers. Okay, and the method that they use also to seek the answers that they're looking for. Okay, it is very important to realize that economics is a science. Okay, it is known as a social science. And social science is not a hard science like mathematics and physics and biology. It's a social science, and you will understand why it's called a social science in a second. Now, it is a science because it uses the scientific method. All right, and the scientific method is defined as the dispassionate development and testing of theories about how the world works. Now, this word is very important, the word dispassionate, because we have realized over time that scientists actually include, or they use their passion in doing science, but true science actually does not involve passion. Okay, it is fact based. Okay, all right. So Albert Einstein said to that effect, the whole of science is nothing more than the refinement of everyday thinking. Okay, so we said that economics uses the scientific method. What is the scientific method? Well, first you observe a phenomenon. Based on your observation, you develop a theory, and after developing the theory, you try to observe more in order to check that the additional observations are in line with the theory that we developed. Okay, so let's use the theory of gravity as an example. Now, it has been said, and again, it's not really proven or anything like that, but it has been said that Isaac Newton one day saw an apple fall to the ground. So when he saw the apple fall to the ground, he developed the theory that, okay, every object around planet Earth will be attracted to planet Earth. Okay, and this was called the theory of gravity. So, more observations actually were in line with the theory that was developed. Most objects in the atmosphere fall to the ground. So, the conclusion is that this theory, okay, is a good theory because it adequately explains what we observe around us. It adequately explains how the world works. Okay. Well, in economics, this is an example. So, in the first chapter, remember we said that prices rise when the government prints too much money, okay? And this phenomenon is called inflation, right? So, let's assume that the theory of inflation or the term inflation, we live in a world where inflation as a word or as a concept does not exist. But, as an economist, you observe that prices rise whenever the government decides to print more money. Okay, well, you can then develop or create that theory and say, okay, money growth leads to higher inflation. Okay, printing more money will increase price levels. All right. Okay, so you need more observations. Okay, well, more observations here will only come as a result of looking at other economies in other countries. Okay, so if you live in the United States, you will have to check in the UK if prices rise when the government prints more money there. You have to look at Spain and Italy and so on and so forth. Okay, so the observation is the rate of inflation always increases when the government prints more money, as observed in international data. Okay, so conclusion, the theory adequately explains how the world works. So this is known as the scientific method. Once again, observation, theory, and then more observation. Now, in economics, okay, we make use of the scientific method, but the major setback that we experience is experimentation. Okay, so physicists, chemists, biologists, they can run their experiments in a controlled environment in a lab, and they can generate data this way. But in economics, it is impossible to do that. I mean, let's take the example that we just talked about. All right, so we said that, okay, if the government prints more money, then the price is going to rise, and you want to observe more of it. Well, you cannot observe it by asking your government to keep printing more money just because you want to find out whether prices rise. You see, so experimentation in that sense is a problem, when it comes to economics as a science. And actually, this is why it is called a social science. It is not a hard science because we can't experiment. It is called a social science because it uses historical data. Okay, so economists cannot repeatedly increase the money supply of an economy. They can't just change the prices of goods and services just to find out what's going to happen. They can't just change the interest rates, okay, in order to study the resulting effects on the economy. They can't do that. Okay, so they can only rely on data generated by history. Okay, what has happened in the past, locally, internationally, regionally, So whenever the rate of inflation rises, we see that, okay, there's a decrease in unemployment. Okay, because this has happened many times in the past, well, then this theory that there's an inverse relationship between inflation and unemployment must be true. Okay, the production power of economies usually increases following a major technological innovations. Okay, this is something that happened a few times in the past, so we can develop a theory saying that, okay, technological innovations will increase the production power of economies. As examples, we have the Industrial Revolution in the 18th century in Europe, and the dot-com revolution in the 2000s, the Silicon Valley and all that. Okay, so we're still talking about economics as a science. So we just explained that economics uses the scientific method. Therefore, it is a science, but we cannot experiment in economics, so it's a social science. Okay, but we also need to make assumptions in economics. Like in every science, by the way, it is important to make assumptions. Let me explain something. Okay, now to me, guys, one of the most impressive developments in technology to me is the GPS. Okay, I think it's actually great. Right? It allows us to have accurate maps, real life traffic conditions, temporary speed limits. This is really awesome, guys. I mean, can you imagine? You can go wherever you want, okay, without even, thinking about it because you can use the GPS. Okay. Now, when I got my first job as a professor at Louisiana Tech University, I had just graduated from Auburn University in Alabama. So I had to move, from Auburn, Alabama to Ruston, Louisiana, okay, home of Louisiana Tech University. And of course, I used the GPS because I had never heard of Ruston to begin with, okay, and I had to go there. So again, I used the GPS. Now, this is what Google Maps, told me about my trip. Okay, if I use the I-20, it's going to take me 7 hours and 1 minute. Okay, and I was driving, of course. I wasn't taking a plane, and that would be the shortest way, of coming to Ruston from Auburn. All right, so the question is, how did Google Maps know that I was going to take, 7 hours and 1 minute. And actually, guys, if you have ever used Google Maps, which I'm pretty sure you have, it's actually pretty accurate. Of course, it's not accurate to the second, but overall, it's pretty accurate. Okay. Now, in order to develop this level of accuracy, Google Maps has to make some assumptions. Let's take a quick look at a few of them. So the assumptions taken, okay, or the main assumption taken by Google Maps, and again there are a few others, is that the traveler will drive at a speed which is equal to the speed limit wherever he or she is between Ruston and Auburn. Okay, so on the I-20, for example, the speed limit is 70 miles per hour. So Google Maps assumes that this is going to be a speed. On the I-85, 70 miles per hour, highways, average of 65, and in cities the average is 45, and so on and so forth. Okay. Now, is this assumption true? Okay. Well, it is not necessarily true. Some people here have a need for speed. Other people are a little more, cautious on the road, and so on and so forth. So the assumption is not true for everybody. However, it is a good assumption, and that's what really matters. Okay. And because the assumption is good, okay, well, this is why Google Maps, does a really great job estimating how much time it will take you to get to your desired destination. Now, let us look at the role of assumptions in other fields. Okay, if you ask a physicist, okay, how long it will take a marble to fall from the top of a building, okay, or to the ground, well, the physicist can actually calculate how long it will take a marble to fall. But then the main underlying assumption is that the marble will fall in a vacuum, which is not true, because you see, the air is not a vacuum. There are so many things, atoms, there are, so many things actually in the air, right? But this assumption that the marble will fall in a vacuum is not true, but it is good, okay? Because even though the building is surrounded by air, okay, the friction that is going to be applied to the marble as it falls down is negligible, okay? So even if we assume that it does not exist, the results are not going to be affected significantly, okay? But if, the question was, okay, how long is it going to take for a beach ball to fall to the ground, from the top of a building? Well, this assumption that there is no friction, okay, is not going to be true. So the assumptions that we make actually depend on the situation. They depend on the context. Very important. Okay. So as economists study the world, they too make assumptions. And the practice of scientific thinking heavily relies on making good assumptions. Okay. So, in this course, we will be making many assumptions to study, economic phenomena around us. Okay, now let's talk about economic models. Models are a simplified representations of an actual object or an actual subject. Okay. An example, baby toys. Okay. Animals, cars, houses, maps, pictures, these are models of real life representations. Now, I am pretty sure that many of you have never seen a giraffe, or that many of you have never seen a rhinoceros. Okay, maybe some of you have, but I'm pretty sure many of you haven't. However, if you see a rhinoceros in real life for the first time, you will recognize the rhinoceros simply because you have seen many models of a rhinoceros. Maybe on TV, whatever you see on TV is a picture. It's not the real rhinoceros right in front of you, right? So we can see it as a picture. Or maybe you had some animal toys when you were a kid, or you've seen pictures, you've seen drawings of a rhinoceros, with the big horn and all that. Okay, so once again, a model is a simplified representation of an actual object or subject. Models only focus on the important features of the object or subject they represent. Now, let me give you an example. Let's assume that you walk into a clothing store and, as a lady, maybe you want to buy a dress, and as a guy, maybe you want a pair of jeans or something like that. Okay. Now, in clothing stores, they usually have mannequins. Okay. And the goal of a mannequin is to tell you or to give you an idea of, whatever you want to buy would look on you if you wore it. Okay. So that's the main goal. So a mannequin actually is a model of the human body. Now, let's assume that you're walking around the store and you inadvertently, push one of the mannequins. You touch it and then it falls to the ground and then it breaks apart. And when it breaks apart, can you imagine, if after breaking apart you see like a red fluid coming out of it, some organs coming out of it, some veins, and you see a liver, a heart. I mean, sorry for this, kind of graphic example, but can you imagine if you saw all this in a mannequin in a clothing store? You'll be wondering, what? I mean, why did they have to do that? I mean, it's not really needed. Everything that is inside the human body is not needed for the purpose at hand, which is I just want to know what this dress would look like on me if I wore it, right? So this is really what a model is. A model is a simplified version of a real object or subject. Um, and if you want to make it too complex so that it looks like real life, then it's really not needed because the purpose at hand does not require this extra complexity. Okay. However, in a hospital, if you have, medical students who are trying to learn, surgery, well, then all these organs that were modeled in the mannequin would be needed because we need to know where the liver is, where the heart is, where the intestines are, and so on and so forth. You see, so in economics, the real economy is very complex. So we need to simplify it in a way so that we can study it and study the things that we are mostly interested in. Okay, so economic models are simplified representations of the economy. They emphasize the main features of the economy which are useful for the study at hand. This is a quick example. If you want to study how a major sport event, okay, like the Olympic Games or NBA Finals, okay, impacts business in a city, you only want to include important economic variables such as spending on food, spending on transportation in the city, volume of telephone calls and texts. These are the things that you're going to focus on, okay? But if you want to study how a major sport event affects business in a city, well, as you try to model your city for study, you're not going to include the weather, or you're not going to include, I don't know, things that are really not important for what you're doing. Okay, so this is just a quick example, but we're going to talk about many models in this class, and we'll see a few of them actually. Okay, so an economic model may be in many forms. It could be a graphical illustration, like we'll see in a few minutes. It could be an equation. Okay, in economics we use a lot of mathematics, a lot of statistics, a lot of equations, and these equations, however hard they may look, they actually represent something that we are very familiar with. Okay, because they are models. It could be a table with numbers in it, and so on and so forth. So assumptions are the building blocks of economic models, okay, because they basically determine how simple or how complex our model is for study. Okay, guys, so we are about to learn our very first economic model, okay, and this economic model is called the circular flow diagram. All right. So I told you earlier that economic models can be in the form of a graphical illustration. So this is an example here of a model. So, the first question that we need to ask is, what is the goal of this model? The goal of the model is to represent the interconnections between the main economic agents in the economy. Okay, and you will understand all these things in a few minutes. Okay, so the economy is extremely complex. Okay, there are many moving parts, many agents. Okay, whose actions affect other agents, okay, and we need to kind of make sense of these entire interconnections, but they are too complex to represent in a graphical or using a picture. So we try to simplify it as much as possible. So in this circular flow model, we have two economic agents. The first economic agent, okay, is the households, the set of households. So by households we mean consumers, people, you and I. Okay, the term households refer to us. Okay, you and I, consumers generally. And by firms we mean businesses. Okay, productive units. Okay, entities that produce and sell and attempt to make profit. Okay, so these are the two economic agents. Now, this is a simplified model basically because there are more economic agents in the economy. Another very big economic agent is the government. Okay, that's another entity that whose actions actually affect firms, affect households, and so on and so forth. And there are many other economic agents that we can add. But let us really simplify it because, again, this is not a true assumption. We don't only have these two economic agents, we have more, but it is a good assumption to get a good idea. Okay, now the two agents interact through two different markets. We have the market for goods and services, and we have the markets for factors of production. Okay, so let me quickly talk about that. Factors of production are, anything that you use for producing goods and services. And generally in economics, the acronym used to refer to factors of production is CEL. Okay, capital, land, labor, and entrepreneurship. Even though in this picture entrepreneurship does not show, but these here are called the factors of production. So you cannot produce anything if you don't have at least one of them or a combination of these. Okay, and by capital in economics we don't really mean financial capital like the term is used mostly. In economics the term capital refers to tools and equipment. Okay, so if I'm a baker, for example, a capital product or a capital good for me would be the oven that I use to bake. Okay, if I'm in a construction business and the brick maker that I use is a capital good. So tools and equipments are capital goods. Okay. All right. Now let's talk about the markets for goods and services. So these are the outputs of the production process. So these are the inputs. You need labor, land, capital to produce, but whatever is produced is called a good or a service. So here we're talking about cars, bicycles, laptops. We're talking about taxi rides. A taxi ride would be a service, and everything I've said so far would be goods. Haircuts, and a few other things. Okay, so the interactions happen there. Okay, now let's talk about these interactions now. And the interactions here are represented by the red and the green lines. Okay. All right, now let's start with households because most of us are part of, all of us actually are part of the households. All right, so as a member of society, you need to find a way to make money. Okay, and this is the money that you're going to use for your livelihood, right? Now there are several ways you can make money. So it's either you use your labor, in other words, you have some skills that you want to sell. Okay, you have a bachelor's degree in marketing, you have a bachelor's degree in finance, in economics and whatnot, and you are offering these services to a firm that's going to pay you money, and we're going to talk about the payment of money in a second. Or you have land that you want to rent out, okay, to businesses, and then they're going to pay you for that. Or you have some tools and equipments that you're trying to rent out or sell, and this is how you make money basically. Okay, so you sell all these factors of production in the markets for factors of production. And these factors of production are bought by firms because the firms need what you have. because without you, firms cannot produce any good and any service. This is why firms hire, right? And even, right now we're talking about robots selling people's jobs. Well, this is capital. So these robots are here. Okay, and the robots are developed by people, right? So firms need those. Okay, now once the firms acquire the factors of production, they can now produce goods and services and sell these goods and services in the markets for goods and services. Okay, so they are able to sell financial services. They are able to sell, their consulting services and so on and so forth. Okay, other goods if you are producing for them. And these goods and services that are sold by firms in the markets for goods and services are bought by households. Okay, so this is the cycle here. Households offer the services to firms. Firms use these services to produce goods and services which are then bought by households. So this is the inner layer of our model. Well, the other layer, which is the outer layer with the green arrows, is well, how do households buy goods and services? Where does the money come from? Of course, we can see it here. When households sell their factors of productions to firms, well, firms will pay them wages if it's labor, rent if it is land, and profit if it is capital. Okay, but basically, firms will pay them for their factors of production, and these payments will come in as income. The income that households make is what they're going to use to spend, okay, on goods and services. So once they spend, their money on goods and services, this is revenue. This is money made by the firms, which they use to basically pay again the households for the factors of production. Okay, so this is now the outer circle. So the inner circle focuses on physical things. The outer circle focuses on money, basically. All right, guys, this is the circular flow diagram. All right. So again, even though there are so many other intricacies in real life, which we can talk about in all these interactions, well, the truth is that this is actually a pretty good model. It gives us a pretty solid understanding of the relationships or the interactions that happen between households and firms. And this is the goal of a model, to give you a pretty solid idea, without necessarily having to, look at all the details and all that. And there are several ways of, making this model a little more, a little closer to real life. We can add the government. The government is actually going to, if you add the government, we're going to have tax considerations, because when you spend money, you have to spend taxes. Basically, these taxes go to the government, and the revenue generated by the firm is taxed as well, and so on and so forth. Okay, these are considerations that are not given or that are not taken in the model that you see there. Okay, all right. So in the next slides, I basically explain everything that I just said verbally. Okay, so please take some time and read the slides. Okay, now let's talk about our second and last economic model for this chapter. And this entire course is going to be the study of many economic models anyways, but these are introductory models just to give you an idea of what models are and how to use them. Okay, so we will talk about the production possibility frontier, also known as the PPF. All right, now before talking about the goal of this model, let us, talk about a few things. Economists produce thousands and thousands of goods and services. Okay, it's actually impossible to know exactly how many unique or distinct products, and by products I mean goods and services, are offered in an economy. This is a huge task. But in this model, we will actually make a very, very big assumption. The assumption we'll make is that our economy only produces two goods, Okay, and there are millions actually, but we'll just assume that two are produced: cars and computers. Number two, we will also assume that all the economy's factors of production are used. This is another assumption. In other words, all the land is being used for productive purposes, which is not true because there's so much land which is not being used for any productive purpose. Number two, uh, all the labor in the economy available in the economy is used. Well, this is impossible because at every point in time there is at least some level of unemployment in the economy, right? Meaning that some people who could work are not working, and all the capital is used, so all the tools and equipments are used. This is actually not true, but this assumption is again going to give us a good idea of what this model was to tell us, which I'm going to reveal in a second. Number three, the best technology is employed in producing the two goods. This is also an assumption in the sense that in any economy, some companies have access to the best technology, others do not. So this is not true for everybody. But again, it's just an assumption to make our life slightly easier. Okay, now unlike the circular flow diagram, which is it's kind of like a histogram or a chart of sort. Okay, the PPF is actually a curve. Okay, a curve on an XY axis. And what the curve does is the curve shows the maximum combinations of the two goods produced in the economy that can be produced. Okay, and the two goods, remember, are cars and computers. Okay, so let me show you. This is an example of a production possibility frontier. So on the x-axis we have the number of cars that we can produce in the economy, and on the y-axis we have the number of computers that we can produce in the economy. All right, so I'm going to spend some time on this slide and explain what you need to know about the PPF, and everything that I'm going to explain is on the following slides, so you can take some time and read them. Okay, so remember that one of the assumptions is that all the resources, all the factors of production in the economy are used. So if we use everything we have, all the labor, all the capital, all the land, okay, these are the combinations of the two goods that we can produce. So for example, if we decide to produce at this point, it means that with everything we have, we can produce 3,000 computers, okay? 3,000 computers, but 0 cars. On the other hand, if we are more interested in cars, then we can produce 1,000 cars and 0 computers. So these are the extreme levels of production. But there are, levels of production that are in between, okay? For example, we can decide to produce at point A, and point A means that we're producing 600 cars and 2,200 computers. Or we could decide to produce at point B, 700 cars, 2,000 computers. We could decide to produce at point E or at point F, okay? So all the points on this line are combinations of cars and computers that we can produce using everything we have, okay? Then you see there are 2 points here, D and C. So is it possible for us to produce at point D? Yes, it is. Okay, it is possible for us to produce 300 cars and 1,000 computers because we can actually produce 600 cars and 2,200 computers, right? So D is a point of production which is possible. However, there is a slight problem, a small problem with D. Point D means that even though we can produce it, we are not being efficient because we are wasting some of our resources. Okay, it means that we'll have some level of labor, some level of capital, some level of land which are not used, okay, and they are just wasted. Okay, so D is possible but not efficient. What about C? Well, C is a point of production which is impossible for us, unattainable given the current resources that we have in the economy. We don't have enough land, labor, and capital to produce at C. However, F, A, B, and E are all possible and efficient points of production. Okay. Now, it's impossible to realize here that let's assume that we start at this extreme point with zero car and 3,000 computers. Okay. Now, one of the very important economic concepts which we learned in the first chapter that this model illustrates is the concept of opportunity cost. What you give up in order to acquire something. Okay. Because if we start at this point of production, if we decide that, okay, we have 3,000 computers and zero car, but we need some cars in our economy, well, it means that what you want to do is to start moving down this line and produce at points that are, on other points on the line. But the thing is, as you increase the number of cars you produce, you are essentially also decreasing the number of computers you have. And that's the opportunity cost of producing more cars. The opportunity cost of producing more cars is giving up some computers. Okay, so there is a trade-off, which was principle number one. There is a trade-off in the production. And this is one of the things that we learned from the PPF. It tells us about the trade-off that economists face when they make their production decisions. Okay, so as we speak right now, COVID-19 is happening all around the world. And many resources are being used, especially in the medical field, to develop solutions to this problem, to this medical problem. But you see, when these resources go into finding a cure for COVID-19 and possibly a vaccine, these resources cannot also be used for cancer research. These resources cannot also be used for, research on AIDS and so on and so forth, or other sicknesses. This is the trade-off right there. And this trade-off that happens at every single level of the economy is actually, this trade-off is what this very simple model with only two goods illustrates. Okay. Now, a few years ago, and actually I'd say 2 years ago, we had a spike in the price of bitcoins, okay, and cryptocurrency in general. And more and more people started mining cryptocurrency because they wanted to take advantage of the high price. And in order to mine cryptocurrency, you need special computer accessories that we call graphic cards. Okay, and graphic cards are not designed for mining specifically. You can do many things with graphic cards. People doing 3D modeling or gamers actually need some good graphic cards and a few things like that. So many people started using the graphic cards for cryptocurrency mining. So this was the production decision at the time. But then these graphic cards could not be used for other purposes, okay, like 3D modeling or gaming or whatnot. Okay, so that was a trade-off that happened right there. And again, it can actually this illustration of a trade-off given to us by the PPF can be extended to so many different fields. Okay, so these slides actually explain many of the things that I just said. So please take some time to read them. Okay, now economies grow over time. Okay, and economic growth typically means that an economy can produce more. Okay, they can produce more than they could in the past. So economic growth can actually be illustrated by the production possibility curve, or the production possibility frontier, okay, which is an outward shift of the curve essentially. All right, so let's assume that our current production possibility frontier is the blue PPF that you see there. So when we are at the blue PPF, point A is a point of production which is efficient, okay, and possible. All right, and at that point, G is unattainable for us because we don't have enough factors of productions to reach it. However, through economic growth, the fact that we can produce more means that our PPF is going to shift out, as you see. And after economic growth has been experienced, point G, which once was unattainable for us, is now considered a point which is attainable and efficient, and A is now still possible but now inefficient. Okay, so this is the illustration of economic growth used by the PPO. So this is something else that the production possibility frontier, this simple model allows us to see, to visually understand what economic growth is all about. Okay, so all this space, which has millions of points which once were unattainable, are now attainable through economic growth. Okay, so again, this is what I just explained, right? But let's take a look at this. Economic growth can be caused by several factors. Improvement in technology, okay, because you now have better ways of producing goods and services. It could be discovery of new resources or research and development, and training and teaching, and basically improving human capital, because the more you learn, the more human capital you have, and the more you can do. So this also leads to economic growth. All right, guys, this is the end of chapter 2. So you should now be able to understand what the scientific method is, explain why economics is considered a science, understand the limitations of economics as a science, basically the reason why it is called a social science, understand the importance of assumptions in science, understand what economic models are, understand and explain the circular flow model, understand and explain the production possibility frontier model. All right, guys, so I hope this was clear, and see you in the next chapter.